So these are our notes on statistics on page 12 of our Unit 1 packet. So we do statistics with data or measurements to determine the validity of our measurements. Okay, so we're going to look at what is the accuracy and what is the precision of our measurements. So one of the first things we do if we have two or more measurements that were taken is to find the average or the mean of those two measurements. So you'll need to add all of the measurements up and divide by the number of measurements, keeping in mind that the number of measurements is a counted number and you would not count that number for, that's a big no for sig figs, okay? So number of measurements, no for sig figs. Your measured numbers, yes for sig figs, okay? So keep that in mind as you do your averages. So you'll have to do an average. Range, which you've done before, determines the difference between the high and the low values, okay, or measurements. So you're going to look at all your data points, find the high number, find the low number, and subtract, okay? Percent error determines how close a experimental value is, so something you get in lab is compared to an accepted value, or what we would call a theoretical or true value. So experimental values are from your lab. Accepted values, you look them up. Okay, so either given to you or you look them up. Your experimental value may be an average. All right, so this is the formula for calculating percent error. You need to put this formula just as it is written on your purple formula sheet. Okay, if you have questions about that, let me know. There are 10 units in this class. You've got your formula sheet, right? I would label unit 1 and then put your formula in there. And there's 10 units that you're going to try to fit on that one side. If you can't fit on one side, it's okay. I'll get you another one. Okay. So we're going to do a little practice here. We've got 3 groups that are experimentally finding the melting point of an unknown solid. Okay. So each group has 3 data points, which means we have 2 or more data points that we have to average. So I want you to go ahead and find the average for group 1. Okay, these 74 plus 78 plus 71 divide by 3. You need to do the average for group 2 and the average for group 3. So go ahead and pause the video and find those averages. Okay. So what you should have found with the correct precision is that the group 1 has an average of 74, that's a degree sign, Celsius. Group 2 has an average of 55 degrees Celsius, and group 3 has an average of 72 degrees Celsius. So the next thing we're going to do is find the range of each of the group's results. So this is the high minus the low. So if we look up here at group 1's data, the high number is 78, the low number is 71. So take 78 minus 71, that is a 7-degree difference. The range of group 2, high number is 56, low is 55. So that is 56 minus 55 gives us a difference of 1 degree Celsius. Group 3, you get a high of 84, a low of 60. So 84 minus 60 degrees is a difference of 24 degrees Celsius. So what does that tell us? So we're going to rank these groups in decreasing precision from most precise to least precise. So range tells us precision. It tells us how spread out our numbers are. So if we look at group 2, they only have a 1 degree difference between their high value and their low value, which tells me that group 2 has the best precision. Group 1 is kind of in between. Group 3 is all over the place. Their high value is 84, their low value is 60. So group 3 has the lowest precision. Okay. So what we're going to do next is use percent error to find the accuracy. Okay. We see that the true melting point is 72 degrees Celsius. That is the accepted value. So using our percent error formula, we're going to take the absolute value of the average for group 1, which is 74 degrees Celsius minus 72 divided by 72 times 100. Now, when typing this in your calculator, you need to be careful. Either put these two numbers, 74 minus 72, in parentheses, or do the subtraction and hit enter and then divide. Okay. So for that one, we get 2.8% error. Group 2, you're taking 55 minus 72, absolute value, divided by 72 times 100. And for that one, we get 24% error. So that's a high percent error. Our group 3, 72 minus 72, really easy, divided by 72 times 100 tells us that there is 0% error. So the group that's the most accurate is 3. And we know that because they have the lowest percent error, okay? So what's interesting about group 3 is that their data was all over the place, right? They had this really big range, but on average, it worked out for them, okay? That's why you take a lot of data points, take a lot of measurements, so you can average them, and that improves your accuracy. However, group 2 that had the best precision happens to have the highest percent error. So that group 2 would then need to look at, well, why is my error so high? You know, all of my measurements are close together, but we're really far off the mark. So maybe, you know, am I reading the thermometer wrong? Is the thermometer not calibrated correctly? Okay, they would need to look at that and figure out why they are so far off. Okay, so these are the kinds of simple statistics that we're going to do with when we have, you know, 2 or more data points, or if we want to check for accuracy with percent error.